QDS supports PySpark, Spark, Spark-R on Python kernels for Jupyter Notebooks. Select the kernel of your choice. This opens a new notebook window. Provide a valid name for the notebook and click Create to create a new notebook in your working directory. Every notebook opens in a new tab. QDS enables offline edits to notebooks, meaning you can create and edit your code even when the cluster is offline. However, you need to bring the cluster online to execute the notebook. If a notebook is created when the cluster is offline, Cluster on the top right of your main work area shows the cluster is unattached. Click the cluster's drop-down and select the cluster. If you select an offline cluster, the cluster starts automatically. Note that one notebook is attached to one cluster. The offline edit feature is disabled by default. You need to contact the Qubel support team to enable this feature. Next to the cluster is Kernel. The empty circle indicates an idle kernel. The circle with the crossbar indicates a disconnected kernel, and a filled circle indicates a busy kernel. The kernel is disconnected when the cluster is offline. To change the associated kernel, click on the kernel name. From the Select Kernel dialog box, select the appropriate kernel and click Select. Let's select PySpark at this instance. The status bar at the bottom of the main work area also shows the status of the cluster and kernel along with other information. Now that you have the cluster attached and the kernel connected to, you're all set to write commands and run the notebook. Use the Markdown text to provide a description of the workflow. This not only helps you organize the notebook, but also helps others to understand the workflow. Click this drop-down in the toolbar and select Markdown to enter the Markdown text in the selected cell. Following the Markdown text, enter the query. Go back to the same drop-down list in the toolbar and this time select Code. This allows you to enter a query in the selected cell. As we have selected the PySpark kernel, let's enter a Spark command and click the Run icon. Notice that as the Spark job executes, the kernel ID and the other information are displayed in the main work area. The output is displayed below the query block upon successful execution. You can leverage the machine learning libraries like Plotly, ggplot2, and matplotlib built into Spark to visualize the output. Use the toolbar above the main work area to perform the most common actions, like saving notebook, copying cells, executing paragraphs, etc. The widget shown as down arrow next to kernel name displays the Spark application status. Additionally, it provides links to the Spark UI, driver logs, and kernel logs that are useful for monitoring and troubleshooting. Note that this widget is available only for Spark kernels. You can share this notebook with other users. Right-click on the notebook and from the context menu, select Copy Shareable Link. This generates a link to the notebook that you can share with others. You can also define access permissions to other users. Right-click on the notebook and from the context menu, select Manage Permissions. On the dialog box that opens, select the users or groups and select the appropriate permissions and click Save. There are many other actions available at both notebooks level and cell level. Use the context menu to explore those actions yourself. Furthermore, you can create a schedule for the notebooks to run at a particular time. Select the notebook you wish to create a schedule for. Navigate to the Scheduler function and click the Add icon. This opens the Scheduler interface where you can enter the required details. Adding macros will automatically substitute the given values whenever the notebook executes. Populate the schedule details and click Save. When you go back to the notebook interface and select the notebook, you can view its scheduled jobs along with a snapshot of the execution in the Scheduler panel. You can select a snapshot and view the output generated at a scheduled time.